Hello guys, welcome back to my channel Hanmant Reddy tutorial of Maths and Physical Science. So now in previous class we discussed about Euclid division algorithm. Now we are same concept. I am discussing about Euclid division algorithm. We have to learn more and more subject about Euclid division algorithm. I told the difference between division algorithm and Euclid's division algorithm. What is the major difference? Division algorithm is just only to find out quotient and remainder. But in Euclid division algorithm, we are going to find out HCF. The main purpose of division is to find out quotient and remainder. But in Euclid division algorithm, we will proceed for the division till we get a remainder 0. So let me explain division algorithm. We know in the previous class division algorithm formula dividend is equal to divisor into quotient plus remainder plus remainder remainder. Okay, so I told you this is the formula for division algorithm where 0 is less than not this is 0 is less than or equal to remainder is always less than divisor. Remainder can never be equal to divisor. Sir, why we got this condition? What is the meaning of this condition? Let me discuss about these conditions throughout this day today about this Euclid's division algorithm, about this condition. After that I will move to fundamental theorem of arithmetic, HCF and LCM. That's it. Today wind up. So up to this three concepts we will discuss today. Now, okay, in this video class, we'll discuss about these three concepts only concepts. Okay, why shall we? See, in the previous video class, we discussed about terms of division. What are the terms in division? Whatever the quantity we write here, it is always called as dividend. Here we will call the quantity which is written here is called as divisor. This is quotient, and the number which is obtained, the quantity which is obtained here, it is called as remainder. So how we got this condition? Let us explain with the help of examples. Let us take for example. So some questions I am taking nearly some 6 questions. I will do it very fast, right? It's basic divisions. We learned in very earlier classes somewhat basic divisions I am going to explain. For example, now I am going to take some 32 divided by 4, 33 divided by 4, 34 divided by 4, 35 divided by 4, 36 divided by 4, 37 divided by 4, 38 divided by 4, 39 divided by 4, 40 divided up to this. Enough. Just I am doing some basic divisions. I want to complete only basic division. Say, now I am writing, I told as per this symbol, this is dividend divisor. As per this symbol, according to symbol, see, the quantity will change as per the symbol. The quantity will changes according to the symbol. Okay, na? So, dividend divisor, right? So now I'm taking here dividend. Here we have to take dividend. Therefore, dividend is 32. So we will go for 4. Directly we can write 4 is the 32. Remainder is 0. Write the terms in the division. What are the terms we obtain? I am writing. Capital D is equal to dividend. Dividend equal to 32. Divisor equal to 4. Quotient equal to 8. Remainder equal to 0. So so these two are very important. Now I am focused on this divisor and remainder. Next, go for 33 divided by 4. 4 is the 32. Remainder is 1. Stop. I don't want to proceed in the decimals. Okay, na? So again write down. I am writing just divisor 4, remainder 1. Just to focus on this. Divisor 4, remainder 1. Next, 34 divided by 4. 4 is the 32. 2 is the remainder. Again divisor is 4, remainder is 2. Next, 35 divided by 4. 4 is the 32, remainder is 3. So divisor is 4, remainder is 3. Next, now go for 36. 36 divided by 4. 4 9 is 36, remainder is 0. So divisor is 4, remainder is 3. Now again go for 37 divided by 4. 4 9 is 36, remainder is 1. So divisor is 4, remainder is 1. Next is 38 divided by 4. 4 9s are 36. Remainder is 2. So divisor is 4. Remainder is 2. Guys, just this is the basic division. What we learned in the earlier class. That's why I'm going to do very fast. Okay, na? So 39 divided by 4. 4 9s are 36. Remainder is 3. Now 40 divided with 4. Now 4 10s are 40. Remainder is 0. Remainder is 0. Okay, 40 minus 40 0. So divisor is 4, remainder is 3. So divisor is 4, remainder is 0. Now I will explain very slowly. Okay, I will go. So if you observe carefully, all the questions contains divisor 4. All the questions contains divisor 4. Okay, listen very carefully. All the questions contains divisor 4. Divisor is 4 for all the questions. But observe carefully remainder. Now first coming to remainder number. First remainder 0, 1, 2, 3. Now 4, 9, 36. Here remainder is 0. Okay, remainder is 0. 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. Sir, now we observed very carefully. If divisor is 4, the remainders we are observing as 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. You take the dividend can be any number. You take any number as dividend. But there are fixed reminders, means possible reminders. There are possible reminders. What are those possible reminders? Each and every question we have reminders starting from 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. That means the minimum reminder can be 0. See, the remainder always how much we can't say. It depends on the dividend. I can't say whether how much quotient or remainder exactly. I can't say quotient exactly, but I can say what is possible remainder, because quotient depends on the dividend and also divisor, but remainder only depends on divisor. Remainder only depends on divisor. See, I can say what is possible remainder. Sir, if divisor is 4, possible remainders can be 0, 1, 2, 3, 0, 1, 2, 3. But divisor is 4, 0, 1, 2, 3, 0, 1, 2, 3. But means if you observe, the minimum remainder can be 0 for any divisor. If divisor is 5, for example, if divisor is 5, possible remainders can be 0, 1, 2, 3, 4. If divisor is 6, the possible remainders can be 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Means, if you observe very carefully, the minimum remainder can be 0 and the maximum remainder is always 1 less than divisor. See, if divisor is 4, the maximum remainder is 1. Reduce number 1. Reduce by 1, you will get 3. If divisor is 5, maximum remainder is 4. If divisor is 6, maximum remainder can be 5. Means, if you observe very carefully, so reduce 1 to the divisor, reduce 1 to the divisor, reduce 1 to the divisor. That is the maximum remainder. So what is that condition? So now from all these remainders, you can observe minimum remainder can be 0 or it can be greater than 0. Yes, am I right? Yes, it can be greater than 0 and also it is less than divisor. Less than divisor. It can never be equal to divisor or greater than divisor. If divisor is 2, 0, 1 is the remainder. If divisor is 3, 0, 1, 2. If divisor is 4, 0, 1, 2, 3. It can never be equal to divisor or greater than divisor. So therefore, now these three conditions combined together, we can write in the, see, remainder can be 0. See, remainder can be 0. 0 means this is the equal to symbol. Remainder can be 0 or remainder can be greater than 0. If you write in reverse order, Nana, for example, if you write this condition in the reverse, compare in reverse direction, that is nothing but 0 less than remainder. 0 less than remainder. Now combine these two conditions. 0 less than, see, exactly 0 and less than remainder. See, 0 equal to remainder. See, 0 equal to remainder. 0 equal to remainder. This is the meaning. 0 equal to remainder. 0 less than remainder, which is less than divisor. Now combining all these three conditions, we got that conditions in Euclid division algebra. I hope this is very clear for you. I hope very clearly. I think you understood very clearly. If a remainder is 10, possible remainder can be up to 0 to 9. Now, if for example, sir, if they ask in terms of variables in the objective, sir, if the remainder is n, sorry, if the divisor is n, for example, if the divisor is n, let's take for example, if divisor is n, for example, what is the possible remainder? Divisor is n. Yes, sir, if divisor is n, for example, what are the possible remainders? Divisor is n. What are the possible remainders? It may be 0 to 0 to 0 to n minus 1. Remember this, 0 to n minus 1, 0 to n minus 1. This is the possible remainders. If divisor is n, the maximum remainder is n1, n minus 1. For all the question, for any divisor, the minimum remainder is always 0. Minimum remainder is always 0. I am not asking fixed remainder. I am saying that minimum remainder. Minimum remainder is always 0 and maximum remainder is, it will be less, one number less than the divisor. Okay, actually 1, reduce 1. So this is about Euclid condition of the Euclid division algorithm. What is the condition? What is the condition? Dividend equal to divisor into quotient plus remainder where 0 is less than or equal to r is less than divisor. It can divisor, right? If divisor is a, right here divisor. If divisor is b, right here divisor b. If divisor is n, right here divisor n. So what is the meaning of, for example, if divisor is 10, for example, if divisor is 10, so from this I can say that 0 to 9 are the possible remainder. 0 to 9. 0 to 9 are the possible remainders. I hope this is very clear for you all. I hope this is very clear for you all. So from this I can say that now one more in division algorithm I want to know about that. If remainder is 0, what will happen? What is the term is called? What so and so, so and so. We will discuss it now very clearly. Now coming to which is very very important for your irrational proofs. Now I want to discuss one thing, only one thing I want to discuss about the word divides or factor. Divides or factor. What is the word divides or factor? Now listen very carefully, it's very very important, very carefully listen, and it's very important, right? Very very important. So I'm going to discuss about the word divides, divide, not divides. The word divides or factor means in the process of division, if you get exactly remainder 0, if you get exactly remainder 0, it is fixed. Other than 0 it should not be. If the remainder is exactly 0, then we call divisor is called factor of dividend. Divisor is called divisor is called factor of dividend. Factor of dividend. Divisor is called factor of dividend, or I can say divisor divides, divisor divides, divisor divides dividend. Divisor divides dividend. This is the word I can use. Divides or factor, both are same. It is nothing but in the process of division, if we get the fixed remainder 0, then we call divisor is factor of dividend. Let me go with an example, one simple example. Let us take 6 is divided by 2. 6 is divided by 2. So 6 is dividend, 2 is divisor. 2 3s are 6. So 0. So in terms, I'm going to explain further deep in terms of mathematics. So what I can write now, listen here, listen very very carefully. Now I can write in terms of division algorithm. As per division algorithm, I can write this step. Now I am converting as per division algorithm. Write in terms of division algorithm. Dividend is equal to, dividend means 6. Dividend is equal to divisor into quotient plus remainder. Divisor is equal to quotient plus remainder. See, this is always called as divisor. Never say this is divisor. As per the problem, this is called as quotient. As per the problem, don't say 3. 3 can become divisor and it remainder is also 0. But it depends as per the question. As per the question, here 2 is the only the divisor. 2 is only the divisor. 2 is the divisor. So Now, what is the meaning of 2? Can you say me? I can write like this also. 6 is equal to 2 3 are right. Yes. Can I write like this also, right? Yes, I can write 2 3 are. No need of writing adding 0. But always remember, in terms of addition, 0 is not countable. 0 can never be considered under addition. So if you can, it may be visible or it may not be visible. It's no problem. You can put to 0 under addition or no need. So listen very carefully. 2 into 3, it's nothing but definitely 2 is the factor of 6. 2 divides 6. I can say from here. See, something is equal to something into something. There is no number under addition. There is no number under addition. Therefore, it is called as factor or divides. So from this question, I can say that divisor is 2. I wrote very clearly. Divisor is called a factor of dividend. That is nothing but 2 is the factor of 6. 2 is a factor of 6. Or I can write 2 divides 6. 2 divides 6. So factor meaning fixed remainder 0. Divides meaning fixed remainder. So that means I can apply division algorithm on this also. As per the division algorithm, I can apply division algorithm on these two numbers also according to that statement. According to that statement, I can apply division algorithm on these two numbers. That means this is always divided, this is always dividend. So now, as per the word statement, remainder is 0. The word divide, sorry, the word divides, remainder is always 0, or factor, the remainder is always 0. So apply division algorithm on these two numbers. On the two quantities, apply division algorithm, nothing but dividend is equal to, I am writing formula, I will write in terms of shortcut, dividend equal to divisor into quotient plus remainder. So now dividend is 6, 6 equal to 2 into 3 plus 0. Means you can get any something. 3 can be quotient, right? And quotient can be, yes. I told you very clearly, the main purpose of division is to find out quotient and remainder. Yes, we don't know quotient, but we know the remainder. I can write like this. So something plus 0 is always something. 6 equal to 2 into 3. I can like this. So we apply division. How to apply division algorithm on those two quantities? Yeah, I hope you clearly understood how to apply division algorithm. This point and this step, this process, this procedure is very important in writing irrational proof. Very important in writing irrational proof. So remember this completely. Remember it. So I will share this as a PDF file in the form of images. I will share it. Okay. So from this, I hope this is I hope you understood very clearly. This is very clear for you all, right? Thank you. Now let me go for next class. Is the next concept name is fundamental theorem of arithmetic. Then I will HCF and LCM. Just I will explain only the concept. In the other class, next video class, I will discuss about only problems, just concept wise problems. I can't discuss each and every problem because this is not our academy or school. This is not. So I will explain very important, very important questions, which is based and the previous year questions also. But I will explain two or three problems based on the concept. Now let us move to, so I hope the concept of Euclid's division algorithm is very clear for you. Next I am coming to fundamental theorem of arithmetic. So before going to learn fundamental theorem of, you should learn the what are prime numbers and composite numbers. Prime numbers, so I will make you learn logically how to remember prime numbers and composite. And logically, I will make you remember. So let us learn prime numbers and composite numbers. After that, I will explain fundamental. See, these are necessary, Nana. But for learning the subject also, prime numbers and composite numbers are there in fourth and fifth and sixth classes. But learning is all we have to learn. Learning will not affect, right? So we have to learn. So let us go logically how to remember. Prime number means exactly two factors, composite means more than two factors or minimum three factors. No, just try to remember what are the examples. It's enough. Okay, so now I'm going to classify prime numbers up to 100. Prime numbers up to 100 I'm going to classify. Remember it logically. Logically means no one can say logic of a plus b whole square. They have to revise the formula, memorize in that way, in the rot method. So remember this prime numbers up to 100. It's very important. For probability also the same. Nana, the concept of prime numbers, each and every number is important in the concept of probability for 3 marks and for long answers. Okay, so let us remember these prime numbers up to 100 logically. So let me go prime numbers up to 100, from 1 to 100, from 1 to 100, not up to 100, from 1 to 100, whatever it may be, from 1 to 100 you are going to learn. Now before going to learn, first of all remember it, blindly remember the most important part. One is neither prime nor composite. One can never be prime number, one can never be composite number. Remember it. One is neither prime nor composite. Why sir? Why sir? Why sir? One is neither prime nor composite. Nor composite. First most important point. First most important point. Why sir? One is odd number. Obviously. Obviously one is odd number. Very very important. Means one is called as universal factor, and one has only exactly one factor. It is one. That's it. There is no other factor other than one for number one. Okay, there is no other factor other than one for number one, right? So one is neither prime nor it has exactly one factor only. But prime number means I need exactly two factors. Composite number means more than two factors. Okay, na? So one is neither prime nor composite means don't write one in prime number, one in composite number. Remember it. First most important point is one is neither prime nor composite. Now I am going to divide it in the terms of groups. First learn 1 to 50 what are the prime numbers and how many prime numbers, and again then 51 to 100 how many prime numbers, what are those prime numbers. Now divide 1 to 50 prime numbers. 1 to 50 there are total 15. Total prime numbers are 15. Total 15 prime numbers. Sir, from 1 to 100, from 1 to 100 total prime numbers are 25. Total prime numbers are 25 from 1 to 100. Remember total 25 from 1 to 100. So next from 51 to 100 total 10. 51 to 100 from total 10. 51 to 100 from total 10. Remember like a telephone number code. Telephone number code. From 1 to 50 divide into group wise 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. Next 51 to 60, 61 to 70, 71 to 80, 81 to 90, 91 to 100. Now so remember it from one. Remember like a telephonic code. Telephonic code. First group 4, second group 4, third group 2, fourth group 2, fifth group 3, double 4, double 2, 3. Remember like a number of prime numbers. First group 4, second group 4, third group 2, fourth group 2, fifth group 3. Double 4, double 2, 3. Remember like a prime number. Double 4, double. But surely remember 9 is not a prime number. Surely remember it. Let us remember like a group wise. First group only single digit. Next group I am going to divide it into group. Now I am going to remainder 1 to 10 prime numbers. Total 4. No, first group 4, right? So what are those? Only 2, 3, 5, 7. That's it. Single digit prime numbers are exactly 4. Never cross 7. 2, 3, 5, 7. 2, 3, 5, 7. 2, 3, 5, 7. Remember it. 2, 3, 5, 7. Next is 11 to 20. Next is 11 to 20. That is again 4 prime numbers. 11, 13, 17, 19. 11, 13, 17, 19. Next is 21 to 30. 21 to 30. That is nothing but 23, 29. 23, 29. 23, 19. See, double 4, double 2, 3. Like that, remember. Now again 31 to 40. 31 to 40. That is nothing but 31 and 37. 31 and 37. Okay. Last 41 to 50. Last group in 1 to 50. 41 to 50. 41, 43, 47. 41, 43, 47. Remember like a telephonic code number. Double 4, double 2, 3. 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 Single digit prime numbers are sharply 4. Never cross 7. 2, 3, 5, 7. 2, 3, 5, 7. 2, 3, 5, 7. 11, 13, 17, 19. 23, 29. 31, 37. 41, 43, 47. Next we will move for 51 to 100. How to, what is the telephonic code for 51 to 100? Double 2, double 2, 3 to 1, right? Double 2, 3 to 1. See, double 2, 3 to 1. Double 2, 3 to 1. This is the telephonic code from 51 to 100. Now 51 to 60 I am writing. 51 to 60. Total 2 prime numbers. Total 2. Total 2. Double 2, 3 to 1. Next I will just wait. 61 to 70. 71 to 80. 81 to 90. 81 to 90. 91 to 100. First remember 91 to 100. Only one prime number, that is 97. 97. 97. 91 to 100. Only one prime number, that is 91 to 100. That is 97. Now coming to 1 double 2 3 to 1, from 51 to 60, 53, 59, 61, 60, 61, 7 6 13, 67, 60, right. Next 71, 73, 79. Next 83, 89. That's it. Yes, correct. Double 2 3 2 1, double 2 3 2 1. These are the prime numbers. These are the prime numbers. You have to remember it logic. Double 2 3 2 1, 53 59, 61 67, 71 73 79, 83 89, 97. So whatever the numbers which are missing in the prime number, those are composite numbers. Remember it logically, but one can never be composite number. That is the most number. Whatever the numbers which are missing in prime number, those are always a composite number. I hope this concept is very clear for you. I hope very clear for you. If there is any mistake, rectify me later. Okay, na? Yes, I hope. Yes, I hope this is very clear for you. Remember, like a telephonic code, 44 223 22321. So remember group wise, 44 223 22321. Yes, I hope this is very clear for you all. Next, now coming to fundamental theorem of arithmetic, I am going to write the statement. Fundamental theorem of arithmetic. After this concept, I will wind up this. After this, let me go for again. I will share the video later. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. What is fundamental theorem? Sir, every composite number can be expressed as product of primes. Every composite number can be expressed as product of primes. Every composite number can be expressed as product of primes. Product of primes. Every composite number can be expressed as product of primes. This is the statement. What is the meaning of the statement? Sir, what is the meaning? What is the meaning of this statement? Sir, take a composite number, split into prime factors. Oh, let us take, I am taking a prime number. Oh no, what are the missing numbers in 2, 3, 4, 5, 7? First missing number, don't write 1 because 1 is neither prime nor composite. So first composite number is 4. The least composite number is 4. Smallest composite number is 4. Smallest composite number is 4. So now I am writing as 4. Now 4 can be written as 2 into 2. Yes, 2 into 2 means 2 square. Yes, 2 is a prime number or not? Now I am talking about base, not exponent. Not exponent, okay? Now let next composite number is 6. It can be written as 2 into 3. This is a prime number, this is also prime number, it is under multiplication. Under multiplication. See, product means under multiplication. So this is a composite number. Composite number is in the form of prime and prime under multiplication. Composite number is converted into, composite number is expressed into product of prime and prime. In the same way, next 5, 6, next 7, 8. Let us take 8 is the composite number. It can be written as 2 into 2 into 2. Yes, it is completely under multiplication. Next composite number is 9. 9 can be written as 3 into 3. So from these above examples, I can say that each and every composite number, I wrote every, take any composite number, it can be always expressed as product of primes. Product of primes. Product means under multiplication. So I hope fundamental theorem of arithmetic is clearly understood. I think, is it very clear? I hope it is very clear for you. Okay, what is fundamental theorem of arithmetic? Every composite number can be expressed as product of prime. And so today's concept number 2, fundamental theorem of arithmetic is also completed. Next, let me go for the formula of HCF and LCM. Just I am explaining about that formula. After this concept, I will explain. Next, I will go for the examples. Okay. Next concept is HCF and LCM formula. Remember it. The formula. Just remember the formula. Okay. Just remember the formula. Next is HCF and LCM. If you want to write a notes, I will share it in the form of PDF. But my humble request is that please go through the video class completely. already, my dear guys, all of you, I'm requesting you to subscribe to my YouTube channel, Hanuman Reddy Tutorial. Please subscribe and make it as a 500 member. I will go live, no doubt. I will go live definitely at the time of exams. Okay, na? Please share to your friends for all CBSE and SSC. So I'm sure about it. I will explain each concept related to CBSE and also SSC both. In further days, I will go for ICSC also. That's separate channel for ICSC. But in this channel, I will explain purely SSC and CBSE only concept wise and concept wise question which are very difficult and which are very important. Okay, na? So please share to your friends as many as possible. Please share to your friends and subscribe to my channel so that I can go live. If I'm expecting only 500. That's enough. Not more than 500. I'm not expecting to go live. I may need minimum subscribers is 500. So therefore, share to your friends, to your juniors, and for anyone to other neighbors, relatives, other relatives, neighbors, friends. So thank you. Now HCF formula and LCM formula. Let me go for HCF formula first. HCF. What is HCF formula? What is HCF formula? Sir, product of product of product of common prime factors. Product of common prime factors. Product of common prime factors with see here we know highest common factor. H means highest. Remember, H means highest. Remember it. For highest, the opposite word of highest is lowest. That we remember. With lowest exponents. This is the formula for HCF. Remember this formula. Lowest exponents. I will explain. Let me explain later. I will explain the problem through problem on tomorrow, but I will explain one of the examples. HCF formula, product of common prime factors with the lowest exponent. Next, LCM formula, LCM. LCM, L means lowest. So lowest opposite highest. For lowest opposite it will be highest. Now LCM formula, product of all prime factors. Product of all prime factors. Product of all prime factors with the highest exponent. With the highest exponent. With the highest exponent. Let me go through examples. Just I will explain what is this. So I am not explaining about 12 or 13 cents. Let us take there is one of the numbers. Let us take some number is there. It can be written as 2 square into 3 into 5 square, and one of the number which can be expressed as 2 into 5 cube into 7. Next, let us one more number is there. Let us take it as 2 cube into 3 square into 5. Okay. Now I want to calculate LCF and LCM. Now please concentrate carefully. Please focus your mind on this problem. This is very important for 2 mark question. 100%. Damn sure question for CBSE and SSC both. So for all these three numbers together, combined together, like whatever it may be, the number I don't know. Let us leave. They gave some number expressed in the form of prime factors, prime factors, prime factors. So for all these three numbers, how to find out itself? As per the formula, let us go for product. Product means first take common prime factor. See here the word for all. 2 is common for all. Yes. 3 is common. No, because 3 is absent here. So 3 is not a factor in this. 3 common. I told very clearly. For complete three numbers together, the common factor is 2, right? So 2 is a common, right? 2. Yes, common prime factors, and also 5 is common for all. After writing common factors, now for that common prime factors, write lowest exponent. For 2, what is the lowest exponent? See, for understanding, I am writing here 2 square, 2 power 1, 2 power 3, because 2 is repeated one time. So what is lowest exponent of all? From these three factors, from these three combined together, the lowest exponent is 1. So that is the formula. Common prime factor with the lowest exponent. Common is 2, from all common is 2, and lowest exponent is 1. Therefore now completed. Next, what is so same similarly 5 also, 5 power 1. So answer is 2 repeated one time, 5 repeated one time. Answer is 10. This is the way how to write HCF. Once again repeating, Write common from all take s2 is common, s3 is not common, 3 is present, 3 is present, but 3 is not here. Okay, so 3 is not common, 5 is common, 7 is not common. Next, LCM. Right, what LCM? Write all prime factors. Write all prime, write all means whatever, say 2 is present. Now I am not asking combined together. Write all, s2, s2 is present, 3 also present, 5 also present, 7 also present. Write all prime factors. Sir, I am not asking to write but completely common. He didn't mention the common. He is asking product of all prime factor, means 2 is a factor, 3 is a factor, 5 is a factor, 7 is a factor, 2 is a factor, 3 is a factor, 5 is a factor, 7 is a factor. Write all factors from all the numbers, all the given 3 numbers. So now select the highest exponent. For 2, what is highest exponent from all? From all completely 3. For 3, what is the highest exponent? 2. For 5, what is the highest exponent? 3. For 7, what is the highest exponent? 1. Is it clear? Don't write common, write all. All. 2 is S2 is one of the factor, 3 is one of the factor, 5 is one of the factor, 7 is one of the factor. After writing the factors, select highest exponent. Select highest exponent from all. For 2, the highest exponent is 3. For 3, highest exponent is 2. For 5, highest exponent is 3. For 7, it is 1. Now write down 2 repeated 3 times. 2 cube means 2 into 2 into 2, 2 into 2 into 2, 2 into 2 into 2, 8, 3 into 3, 9, 5 into 5 into 5, 125 and 7 power 1. What is the answer? You write it. That's the question mark. Multiply all this and write that is our LCM. I hope this is very clear for you. Okay, na? Once again repeating, write only common factors in HCF. Only common means it should be repeated in all the given 3 numbers. Okay, na? I hope this is very clear for you all. Thank you all. Thank you, buddies. Thank you, guys. Please subscribe and share to each and every one of your friends, juniors, and so relatives, neighbors, etc., and call members. Okay. Thank you. I'm winding up the class, so I will share it in the form of PDF. Good day for you all. Good day, all.